In this video, I will be going over the limit of a function and how to solve for the limit of a function using graphing. So the definition of a limit states that the limit as x approaches a of f of x equals L. So if we have a graph here with a curve f of x, and we want to look at what happens when x gets close to a. And we're going to want to look from both the left hand and from the right hand side of the function. So as x gets close to a, our f of x function gets close to some y value, and we're going to call that L. So notice that x does not equal a, and that x is just getting really close to a, and that as it's getting close to a, the y value is getting close to some number L. And the first question asks, what is the limit as x approaches -3 from the left-hand side? So here we're going to follow this curve from the left-hand side all the way to when x is close to -3. And so our y value gets close to -1. And then the limit as x approaches -3 from the right-hand side gets close to the y value -3. And so when the limit as x approaches -3 of f of x, this one does not exist, or DNE, because the left and right hand limits do not equal each other. Then we have the limit as x approaches 2 from the left of f of x. So here we're getting close to 2, and our y value gets close to 2. Then we have the limit as x approaches 2 from the right. So as x approaches 2 from the right, y gets close to 0. And the limit as x approaches 2 of f of x does not exist because the left and right hand limits do not equal each other. And now we have f of 2. So when we plug in 2 to the function, our output is going to be 1, and that's going to be our closed dot. Then we have our limit as x approaches 5 from the left, and that continually gets larger and larger, so that's infinity. And then we have the limit as x approaches 5 from the right, and that also becomes infinity. And then finally we have the limit as x goes to infinity of f of x. So as x gets very, very large, the y value levels off at 1. And notice these two are your vertical asymptotes, and this is your horizontal asymptote.